can just watch this video, which will demonstrate R, or you can have this video on one screen or device and then use R on another screen. We assume in this session that you've already done some sort of introduction to R course, or you know the basics of R. And just to let you know, if you have done our introduction to R workshop, this workshop takes a different approach. We're not going to ask you to type every single line of code into R. Instead, we're going to ask you to concentrate on what the code means. So you can open up RStudio now, ready to use. These are all the subsections of this workshop. This is what we're going to cover. There should be bookmarks that you can use to jump to any of these. And just to make you aware, this session isn't about teaching you statistics. We assume that you already know the basics of statistics. We're also not teaching you how to interpret the results of the statistical tests. So first of all, we're going to recap the introduction to R coding workshop. This is for two reasons. One, to remind you some of the basic functions in R, but also we're going to get a data set in so that we can play with it. So I want you to go to the Maths Skills Centre VLE, then workshops, then statistical analyses using R. You've probably got this already open because that's where this video is. There, open up the statistical analyses using R script. So I'll demonstrate that. If we're in, this is Maths Skills Centre VLE, and here's script statistical analysis using R is. If we click on that and open it, it will open up in RStudio. Now, if you didn't do the introduction to R session, you will need to do this next bit. If you've already set up an introduction to R folder on your M drive which contains a .txt file exam marks, then you can skip this part. So what we want you to do is, in the Maths Skills Centre VLE, there's a file called exammarks.txt. Open that up. Then go to your M drive and create a new folder called Introduction to R. Go back to the .txt file, right click it and save as, and save it into that Introduction to R folder. So in case that's not clear, I'll demonstrate what I mean. Go to the VLE, open up exammarks.txt, and this is a file where each row is a student, and we've got their gender, what faculty they're in, how long they report that they've spent revising, an anxiety score, and marks of an exam. Then I want you to go to your M drive. So this is my M drive here. And I've created in here a folder called Introduction to R, just by right clicking and creating a folder. If you do the same, then right click on this TXT file, save as, and navigate to that M drive Introduction to R folder and save it in there. I've already saved it here. Just going to close that down. So now we're ready to run the first line of code to tell R which folder the data is in. So we use this function here called set working directory. And we're telling it that to look in the M drive in the Introduction to R folder. And this name has to be the exact name that you've given that folder. So remember, in R, you can click anywhere on a command, and you can either click this run button here at the top of the script, or what I like to do is press Control and Enter on the keyboard. And that will run it in the console window. This script will contain lots of messages in it, little notes in it. Please feel free to add your own notes to it so it makes sense to you at a later date. So now we've told R what folder our data is in, we can get our data into R. And we're going to do that using read.table. So read.table, we're telling it to look for a file called exammarks.txt. And we've got an argument here, this header equals t part tells R that the first row are the column names. Our exam data is just what we're going to call the data frame. We could have called it anything. And once we've read that in, we could do a little check to see if it's read it in properly, and also to remind yourself of what this data is. So I want you to use some functions to do that. Use names, string, and head. Sorry, structure. str, structure, and head. So I'll demonstrate that in R now. Let's first of all run our data in. So we're going to run this line of code. And then we'll use names. And we'll pass our exam data object through that. And that tells us what the names are. Another one we could do is structure, str. Run our data frame through that. And it tells us how many observations we have, how many rows and how many columns. And the last one that I think is useful to know about is head. It should just display the first few lines of our dataset. So now we're going to create a variable. So let's just say that this is the UCAS points of all these students, and we want to add that onto the end of our exam data frame. So we'll run this so that R knows what UCAS points means, and then we'll run this line of code, which is going to combine our exam data frame with our UCAS points vector. And then what we can do is click on our exam data under data and just look at that data. So first of all, let's create that UCAS points object. Then let's overwrite our exam data and add UCAS points to the end of it using cbind. And you'll see that nothing happens, so you might just want to check that that's worked. Under here, data, we can click on our exam data and it appears here, and we can see that the UCAS points column has been added to the end. Now we're going to make some plots. To make these plots nice and colourful, we've created this vector. We've named it colours, and it contains red, blue and green, so that the columns of our histogram are going to be coloured in those colours. To get a histogram, we're going to use the function hist, and we're going to ask it to do a histogram of this variable here, this column, and we can indicate that we want that column by writing the name of our data frame, have a $sign, and then the name of the column, the variable. Then we've got two arguments here, xlab and ylab, stand for x label and y label. We've labelled them with the text in quotation marks. And then we're going to say that the colours, or the call, we want to equal this colours vector. So we'll create the colours object by running that, and then we'll run this histogram. And it appears in our plot window here. We're going to install a package now. So remember, some functions come with R, other functions are in packages that we have to download from the internet. So to install a package, we use the function install.packages and we put the name of the package in quotation marks. Once it's on our computer, we can get it into our session using the library function. So maybe in the last session you were using the same computer, so you might already have this ggplot2 function on your computer. So you might not want to run that. You will have to run library ggplot2 though. And the reason we're getting this package is because it includes the function ggplot. So I'm not going to run install packages ggplot2. If you run it, it might take a few minutes to download. That's normal. I am going to run library ggplot2 though. And it's given me a warning message because it's built under a different version of R, but we're not going to worry about that too much. So now we can make a plot using ggplot. We're going to make a plot and then we're going to save it as a file. So to do that, the first thing ggplot is expecting inside the brackets is the name of the data frame we're working from, so our exam data in our case. Then it's expecting what goes on the x-axis, so in our case it's this hours of revision variable, and then what goes on the y-axis, so in our case it's the marks. Then we need to tell it what kind of plot we want. We want a scatter plot in this case, so it uses geom_point to indicate that. And we've got a little extra bit here. We're going to colour this plot according to gender, so that the males will be in one colour and the females will be in another colour. Then we can take this piece of code and insert it into this part of the next command. ggsave will save this plot and it'll save it as a PNG file because we've indicated here how we want it saved into our working directory. So we've set our working directory to be the folder Introduction to R in our M drive, so it's going to put it there. And then please take the chance to add to these hashtag notes that we've got in the script. So let's create this graph and see that that looks okay. And there's some details about how that command works. And then let's save that graph. And it's warning us here that we've got a missing value. So in the hours of revision, we've got a NA in our data set. I'll just show you that here. There we go, there's our NA there, our missing value. And so it's warning us that it didn't include that in the plot. So if we go to our M drive and our Introduction to R folder, we should see, there we go, mygraph.pngs there. We've already done a little bit of data management. We're now going to look at more data management. So there's lots of different ways of managing your data, and there's no right or wrong way, so don't get hung up on doing it the same way that you've seen other people do. There's only more and less efficient ways really of doing it. So what this next section is designed to do is help you understand some of the R methods that people are using. And that's so that you can adapt code that you find on the internet, or that you can create your own from these bits of code. So just to be aware, one of the things you can do in R is make your own function. And you might want to do that if you're going to be doing a calculation lots and lots of times. It would be more efficient just to write a code and apply it. So we're going to use a really simple example we're going to pretend that we want to convert hours into days. So let's just say we've got this hours of revision variable and we want to express it as days, find out how many days it is. So you would do that using this function here, which is actually called, confusingly, function. We've named our function myDaysFunction, and we're going to assign it as a function which will act on this object here, hours. Now it doesn't really matter what we write in these brackets as long as it's the same thing and it relates to what we want it to in our formula which we've written here. So we write function and then what we want that function to work on, and then we use curly brackets to describe to R what we want that function to do. So in our case, we want it to take a number, which is the hours, and divide it by 24. And that's going to be assigned as something called days. And once it's done that, we want it to return days. So we want it to show us what days is, print out days. Once we've created the function, we can test it. So let's just test it on, let's say we've got 72 hours, and then we'll make sure that we get the correct answer. So in R, here's our function. Let's Control Enter to run it. And there's some notes there to help you understand what that command does. And then if we test that function, there we go, we get the answer 3, that's 3 days, so it works. Something else that's quite common in R is to do a loop or a for loop. So loops repeat commands, they're quite common in coding. And what we're going to do is we're going to use that function that we've just created, but we want to apply it to each of the numbers in our hours of revision variable. So we want it to go in a loop repeating this function. To do that, we're going to use the function for, which is a for loop. And we're going to say that for each of the numbers in the variable hours of revision, we want it to do this. We want it to do this function. So using I is a really common convention of just saying that it's the number. We want it to act on the first number and then the second number and then the next number. As long as I is the same as what we put in the curly brackets here. So this is us setting up the for loop, and then we want to say that we want you to use myDaysFunction on each of the numbers and then print the answer. So you'll see what happens when we run that in R. There we go. It's printed the number of days that each of these hours of revision is. So there's our NA value. It couldn't do anything with that. Something else to be aware of is the function map. Now that does the same thing as a for loop. Map is in the per package, and this is part of the tidyverse. So remember, the tidyverse is a collection of packages, and they all have little symbols here. The per one is particularly cute. So what we could do is we could apply our myDaysFunction to the hours of revision variable again. So we're doing the same thing again, but just in a different way. So we would write map, then our exam data, and say that we want to work on this hours of revision variable. And then this is a function that we want it to loop. So it does the same, it will produce the same results as the for loop, but they are in slightly different formats. So this time the results will be an R list format, and we'll look at the difference there. it could be a better way, depending on what you want to do next with that list of numbers. So before we can use per, we have before we can use map, sorry, we have to install the per package. So I want you to use install packages in library. I'll demonstrate that now. So before my map command, I'm going to install per. I think it's got 3 R's. We need to put in some quotation marks here. And I'm not going to run that because I've already actually got it installed, but you can run it and then use the library function to get it into my session. I am going to run that though. So now if I run this line of code to the map, you'll see that we've got the same numbers again. So there's our NA where it can do anything with row 5. But it's slightly different. If you look at it here, when we use the for loop, it's in a slightly different format. And that might be useful. So let's look at some of the functions that come with a package called dplayer. Again, we've used dplayer before when we used mutate, if you joined us for Introduction to R. Again, dplayer is part of the tidyverse. It's here. It's got the function mutate, which will take a variable, change it in some way and add it onto the end of the data frame. It's also got this other function called group by. So that will group your data according to a factor. So let's say gender. And then it's got a function called summarize, which we can use to calculate means. So I'm going to get you to install dplayer. And then once you've done that, we're going to do a really long-winded way of using all 3 of these functions. And that's to demonstrate that there is a quicker way of doing it. I'll demonstrate the quicker way after. So the first thing we're going to do is mutate the anxiety variable. So this is, let's say it's a score of exam anxiety. And we're going to put it into a factor. So any of them below 40 we're going to designate as low, between 40 and 60 medium, and then above 60 we're going to say is high anxiety. So we're going to mutate and create this new factor. So let's go to R and do that. We need to install dplayer, so I'm just going to copy this install packages function and replace the per with dplayer. That's not right. I've forgotten how to write dplayer. I'm going to have to look at it. L-Y-R. There we go. L-Y-R. So I've typed in dplayer there, and then I'm going to replace per with dplayer here. I'm not going to run install packages because I do actually have it already. I am going to run the library one though. And we get a warning message to say it was built under R. Don't worry about that. We also get a message to say that it has some functions which are common to other packages we've got installed, and so they might be masked. They might not work in the way that we expect it to. So now we're ready to use the mutate function. So let's run that. And we've got a new variable now called rExamData plus. So we can see that, sorry, not variable, data frame. We can see there's a new variable here, rExamData plus up here. So now we've made this factor, what we can do is create a data frame that's grouped by that low, medium, high anxiety variable. So we're going to create a data frame called rData by anxiety, and we'll use the function group by. We're working on rExamData plus data frame, and we want our to group that by this variable anxiety. Once we've done that, we can take our data by anxiety and calculate the means of two of the variables. So we're going to calculate the mean for marks and the means for hours of revision. And we do that using the summarize function, which will act on our data by anxiety data frame. And we're asking it to calculate the mean for marks and means for hours of revision. And we've included this argument na.rm equals true or t, just to say that we want to treat that missing value under hours of revision by removing it. So remove NA's equals true. So let's run that. Create our data by anxiety data frame. And again, you'll see that we've got an extra one up here, our data by anxiety. And then we can use that our data by anxiety object to get some means. So we've got the means here according to high, low, and medium. I think it's put in alphabetical order there. I hope you found that quite long-winded, because there's a simpler way to do it, but it can be a bit of a difficult concept to grasp. So we can do it using something called the pipe operator, which is this strange looking thing here, percentage signs with greater than a percentage sign. Now the pipe operator pipes the result of each step into the next, and that means that we can do something all in the one command. So for example, we can take our data frame and then mutate it so that we get an extra variable, which is low, medium, high variable, and then we can group it by anxiety, and then we can summarize. So that's all in one command. It also means that there's no extra objects created, and the pipe operator is designed so that it reflects the way that you would verbally describe what you're doing to a data frame. So hopefully you'll see that this is, once you've written it, quite easy to run, and you get the results more immediately. Another useful function that's quite commonly used is summary SE. So let's just say we wanted to get a summary of the male and the female data separately. We could use this function, summary SE. It's in the RMISC package. So I want you to practice installing RMISC and then getting it into your session using library. And then we can run this piece of code below here. So again, I'm going to do a bit of copy and pasting. I'm going to copy the install packages code in the library code, just because I'm lazy or smart, however you want to look at it. And then I'm going to put in the name of the package. Again, I won't run this because I've already got it in my computer, but I will run the library. Again, we've got warnings because it's not built under the same version. We've also got warnings because it's masking the previous package dplayer. Some of the functions have got the same names. So now we can run this line of code, and it's just a quick way of getting data. So we've got mean here, we've got standard deviation, standard error, and a confidence interval as well. So I hope that will be helpful to you in the future. Just take 2 minutes now to look at what we've done and add any hashtag notes to your script so that it will fully explain what these data management commands are to yourself in the future. something that you commonly do in R when you're doing statistical analyses are testing the assumptions. So I'm going to just go through a few functions that you might find useful to do that. So let's just say that we needed to test the linearity of two variables. We could do a quick scatter plot using the plot function. So here we're going to compare the hours of revision against the marks received for each student in our exam dataset. So we do that by using plot and then the first variable and the second variable, and we're telling R that those variables are in our exam data by using this $sign. So let's run that and create our scatter plot. Use our scatter plot here. Another common test of assumptions is for normal distribution. So I've already said that this isn't teaching you how to do statistics, but please do just consider your sample size when you're thinking about normal distribution, like very, very large and very, very small samples. And my advice is to consider looking at both plots of your data as well as doing tests on the data. So you might be familiar with Shapiro-Wilk test. The function for that in R is Shapiro.test. And we just pass our variable through that function there. So here we've done it on the marks variable. Now remember, this is something that you might want to do if you're checking a normality for a correlation or for a regression. But what it doesn't do is test the normality for each level. So let's say of gender, if we were going to do a t-test to compare males with females, say. So in order to do that, we can use a function called tapply. So that's going to apply the normality test Shapiro.test to the marks variable for each gender. So we're applying this function to this variable according to this factor. So here's Shapiro.test. You can see you've got your p-value there. But let's say we were doing testing normality for our t-test. We want to test both the male and the female. So here's the female and here's the male. Some other ways of looking at the distribution of your data are to create a histogram. So we could use the function hist and to create QQ plot. So here we can use the function QQ norm. So what I want you to do is using that piece of code that we use to run a Shapiro.test, a Shapiro-Wilk test, just change the Shapiro test to hist and then change the Shapiro test to QQ norm. I'll demonstrate that in a minute. And what you could do, remember, is view the graphs for both the genders by using the arrow buttons at the top of the plot panel, or we could adjust the graph display with the code here, par standing for parameters of the graph area. So in R, let's get some histograms and QQ plots. So we'll adapt this piece of code first of all, and we'll just delete the Shapiro.test and put in hist and run that. And here you've got I think this will be for females, it's not completely clear. And then we've got another one. In fact, this is maybe for females and this is for males. But we can use the arrows to go back between the plots. And then let's do QQ plots, but this time let's set that plot area so that we can see both graphs. So I'll do that, nothing happens. And then I'll replace hist with QQ norm. run that, and we should get two. There we go. We've got two plots here, one for males and one for females. Although I will admit this isn't the best because it's not clear what one's male and what one's female. And then another thing you might want to do is test for equality of variance. So we can use the var.test function here. This time though, it works a little differently. Instead of a comma, it's set up so that you use a tilde here. So here we're saying this is the variable that we want to look at, and we want to test it, compare the different genders. There's also functions called Levine.test or Bartlett.test, which you might want to use instead. So if we run that test, let's say test for equivariance, and there we've got our p-value here, which tells us our variance isn't different. So just a note on testing normality of the dependent or the residuals. So for some tests, so let's say the independent t-test, it's okay, you can just test the normality of the dependent variable. If you did test the normality of the residuals, they're going to be similar as the dependent. However, for some tests, so maybe regression or ANOVA, it's better to test the normality of the residuals. So I'm not going to do that now because we've not ran any regressions or ANOVAs. I'm going to show you how to do it after running the regression. So now I'm going to talk about some functions that are used to run some quite common tests. I've called them simple tests here, but just common tests that are used regularly. This is the way that I would recommend you run a really simple chi-squared in R, and it's using a matrix. People can overcomplicate running chi-squared in R. So this method uses the total counts. It's not using the raw data. So we have to calculate those total counts first. So in this case, what we're going to do is see if there's an association between the gender of our students and the faculty of our students. So we're going to calculate the total numbers of females and males that are in the science and social sciences faculty. And we can do that pretty simply using the table function. So we want to table gender against faculty. And you could calculate these totals in another way. You might want to do that. So once we've got those numbers, in fact, let me show you that in R. Let's table those numbers. There we go. So now you can see we've got 7, 3, 6 and 5 are our totals. Once we've got those numbers, we can make a matrix out of them. And the reason we're doing that is because this chi-squared test function works on a matrix. So this object here that we create has got to be a matrix. So we've called our matrix gender faculty. We've said that we want these numbers in it, and we want the number of rows of that matrix to be 2, and we're going to fill them in by rows. So it's going to go 7, 3, then put 6 and 5 underneath. Then we can perform this chi-squared test. So let's make our matrix, then pass that matrix through the chi-squared test. And it's given us some output, but it's also given us a warning, and that's likely because my values are quite low. For correlations, you can use a function called core.test. So here, let's just say we want to correlate the student's anxiety score with their UCAS points, just to see if there's a correlation there. So we put both the variables in the core.test function and separate them with a comma. Now, there's arguments that are used to specify how that core.test is run. If an argument's not specified, then a default is used. So when we run this line of code, there's a whole load of defaults that R is going to use. So for example, the code here specifies as all those defaults, and it's going to do the exact same as this line of code. So you could say that it's unnecessarily to specify these defaults if you know what the defaults are. So I'll demonstrate that in R. Here we are. So here's our really simple line of code, and there we go. We get a P value and an R value down here, and then we'll run that again, and you get the exact same values. So what we can do with those defaults is change them, and that means that we can control the way the test is run. So let's just say that we wanted to run a non-parametric correlation and we wanted to run a Spearman's rank correlation. We would change that method to say equal quotation marks Spearman. And the defaults and all the alternative options for functions, they're listed in the R manual. So you need to have a look at the R manual if you're using these. So let's just run that line again, but this time we'll run it with it method equals Spearman. Delete Pearson, put in Spearman. And there we go, we get our R value and our P value, and we've got a little more message here saying that there were ties in our data. I'm not going to go through running all these tests, but I will give you the functions that are most commonly used. So if we're running a two-sample t-test, which remember is just the same thing as an independent t-test or a student's t-test, we can use the function t.test. And what I want you to notice is that that's the same function that you would use to run a paired t-test, except when you want it to run a paired t-test, you add in this argument which says paired equals true. So that's the difference. And it's similar to Mann-Whitney-U and its non-parametric equivalent, the its paired equivalent, the Wilcoxon signed rank test. So this non-parametric Mann-Whitney-U, we can use Wilcox.test. And then if we've got paired data, which is non-parametric, we would use the same function, but with paired equals t. For one-way ANOVA, we're going to use AOV. We'll look at that in a minute. And remember, if we get a significant result from an ANOVA, we want to see where the differences lie, so we'd want to use a Tukey post hoc test, and in R, the function would be Tukey HSD. And then the non-parametric equivalent of ANOVA is Kruskal.test. And again, the function's there for you. So let's demonstrate an ANOVA. To do this, we need a factor which has more than 2 levels. So just now we've only got gender and faculty, which only have 2 levels. So let's create, again, a variable which is anxiety expressed as either low, medium, or high. So this is us just setting up our data before we do the ANOVA. And we can run this piece of code and then let's pass it through head to make sure that it's worked. So control enter this, and then use head to look at our exam data. And there you go, you can see that we've got this new variable anxiety at the end here. Right, now we've got a variable that we can use in ANOVA to test for differences, and this time let's see if there's differences in the exam marks among students with low, medium and high anxiety. So what we do is we're going to create an ANOVA object. So we can call this object anything we fancy, but I've called it something which reflects what I'm testing. So I've said it's an ANOVA which is testing marks for the different levels of anxiety. So ANOVA marks anxiety. I've used the function here. Inside the brackets, you have your dependent variable first. So this is our marks, and then we use a tilde, and then it's the independent variable here. So anything after the tilde is an independent variable. And what we do then is we pass our ANOVA object through the summary function, and that's how we get the test results. So Control Enter to create the ANOVA model. That seems to be happy with that, and then pass it through the function summary. So here we've got the output of the ANOVA, and here's your p-value here. Let's just go through simple linear regression. To do a simple linear regression, we're going to use the function LM to create a linear model. And then much like we did with the ANOVA, we're going to pass that model through some functions to get the output. So just note here, this is a lowercase l, not a 1. It looks a bit like a 1 in the text that R uses. So I'm going to call my model LM linear model marks against hours. And inside the function, it's expecting the dependent variable and then a tilde and the independent variable afterwards. And then I've just done it this way just to show you that you can do it. Instead of putting our exam data and then $, I've said data equals our exam data. So once we've run that, we've created a linear model. And we're going to pass that model through summary, structure, just so that you appreciate how much information is contained within that model. And then we can also pass it through plot, and it recognizes it as a linear model, and it creates 4 specific plots that help you check the assumptions. And what we can do is we can view all 4 of those plots at the same time by using setting up our plot area parameters so that there's 2 rows and 2 columns. So here is my linear model, and I've written it out twice here to show you that they're exact same. So whether we say data equals our data frame here, or whether we put our data frame in like this, they do the same thing. So now we're going to pass that linear model object through a whole load of things. Let me remind, what was the first one? Summary. Okay, so let's pass it through summary. I'll start typing, there you go, it's got it. And there's all the output for that model. So you can see here, we've got the p-value. Sorry, we've got the p-value here. And then what we're going to do is just show you how much information is contained within that model object by using the structure function. So here we go, we'll scroll up. This is where it starts, and you've got coefficients, residuals, fit values, you've got call, you've got a whole load of information that might be useful to you. And then what's normal to do is pass it through the function plot to check how good the model is. But before we do that, let's set up our plot area so that we display 4 plots at the same time. So we're going to use mf row equals c. Mf row equals c, open the brackets, 2 rows and 2 columns. So we'll run that first. Then we'll run this plot, run our model through the plot function. And you can see here that we get 4 plots. So very, very briefly, because I'm not teaching you statistics here, plot 1 is going to check your linearity. Plot 2 checks the residuals, the normality of your residuals. Plot 3 is checking your residuals for equal variance, what you sometimes call in regression homogeneity or homoscedasticity. And then plot 4 is checking influential values, a bit like outliers. Now, the best article I've came across for explaining what these 4 plots are is this one here. And if you scroll down, he runs the model and then he starts talking about what these are called diagnostic plots, and he talks about each one in detail, and I think really clearly. We can also use that same LM function, linear model function, to do multiple regression. So here, this time I've named my model object LM multiple. I've used the function. I've put the dependent variable on this side of the tilde, and then all my independent variables go on the right side of the tilde. Again, I can use summary to view the results. And the other thing you can do is you can test for interactions in this model. And you do that by replacing these plus signs, which we've got on the model here, with stars above the 8 key on your keyboard. And again, you can use the summary to view that model and compare the results. So I'll demonstrate that in R. Here we're going to run this multiple regression. And then we're going to use summary to look at the results of that multiple regression. I've misspelt summary, so it doesn't recognize what function that is. We'll correct that. So here's your results. And then I'll demonstrate to you that you can also look for interactions. The way to do that is to have stars between all the independent variables. So let's just call this LM multiple 2. And again, I use the summary function and look at LM multiple 2 to look at the output. And there you can see I've got p-values for all the interactions as well now. We would also go on to put them through plot to check how good fit they are, how sound the models are. So there's lots of different types of regression, and just to help you, this is roughly how you would run them in R. So if you have a mixed model, so that's when you've got a random variable, or you might have heard it called a within subjects variable, then you can use this function here, which stands for linear model, mixed effects regression, that's what it is, linear mixed effects regression. And we use that by putting the random variable or the within subjects variable in brackets like this. Then if you want a binary logistic regression or binomial logistic regression, you can use the function GLM. But what you do is you specify what exact GLM you want using family equals, and you write binomial here. Same with a Poisson regression. If you've got count data, it's the same function you're using, except you're changing this argument family to say that it's a Poisson distribution you want. Logistic regression, so but in this case where you've got multinomial dependent variable, you can use multinom or mlogit, and then for ordinal regression, the one I use is polar. The reason I like running regression models in R is because they're really easy to specify the way that regression is calculated. So you can say whether you want to do it stepwise, forwards, backwards. It's easy to control that. And I also like the fact that you get all the information for the model and the output. So when we did the STR, the structure of that model, you can see you've got all the information there if you want to look at it. It's also really quick to run multiple models, and then you can really quickly compare them, maybe using AOV, using ANOVA or something. So I've called this section further tests. These are just less common tests and how you'd find out about them. So R can do a multitude of less common statistical tests, and I feel like that's an understatement. So I've listed some things it can do here, but that's just the tip of the iceberg, really. But if you needed to do one of these statistical routines, then how would you find out about them? So my first place would be going to papers that are similar to what you're trying to do, so published papers, and they'll always report what R functions they used. And you can get lots of papers and compare them and get a feel for what the best function might be. And then research those functions using I think the R manual is probably the first place you'd go to. And then you can be looking at websites and at blogs that people have written about them. And if you're lucky, you might get some code, some existing code that you can just adapt. And if you need to, R's a really good, got a really good community, and people are quite willing to help people run code. So you can always ask for help on internet forums. So I want to try and help you cope with errors that you get them, and you will get them. So we're going to run this code to purposely get an error to then try and figure out what are the possible problems. So here's our error section. So this is us trying to read in this exam mark CSV. So far, we've only been reading in .txt files, but you might want to use a CSV file. So you can see here, we've got an error. The warning message is that it cannot open the file exammarks.csv. It's saying that there's no file or directory. So it could be that we've not set up our working directory. It could be that this read.table is designed for .txt files, and if we're using it with a .csv file, we need another argument. Whereas if we change this to .txt, then it would work because we actually do have a file in our working directory which is called .txt. So we need different code if we're going to run in a different type of file. The next one is trying to run a t-test. So let's see if we can read the error and try and fix the problem. So let's run this a t-test for marks against gender. And it's saying here that we've got object RXA data isn't found, right? So we can see there that we've made a spelling mistake here and we've missed out an M there. Once we correct it, then it runs fine. So use that error to fix the problem. And then what we could do is we could run this code. This is us setting up a matrix, maybe to do a chi-squared. And what I want you to do here is find example code for the function matrix and compare it to try and find out what the mistake is. So I'm going to get you to either Google, or we could use question mark matrix. So let's run it to get a horrible error, but that doesn't really tell us much. So let's just do question mark matrix and run that. So we get the R manual for matrix up on this screen. Sorry, it's a bit small. And what I tend to do in R manuals, I quite like just going down to the examples bit at the bottom. So you can see here, they've got, they made a matrix, they've called them NDAT, they've got a matrix here, they've got C, so if we compare that to ours, okay, so we can see that we've missed out the C part. Let's try running that now. Oh, no, it's not happy. Oh no, it's happy. I had a little cross there. And that seems to be fine now. The other thing you can sometimes do with errors is copy the error, paste it into Google, and more often than not, someone else has had that problem. And you'll find forums where people have asked for help on solving the error. So we've got some exercises for you. The first one is a ggplot exercise. The script has got lots of code for some really common ggplot commands. So they're common graphs that you see in papers. I'd advise you just to create these graphs by running the code and noticing what changes each time a layer of that ggplot command is added. So I'll show you that in here. Oh, and I should say as well, sorry, this next section, there's an in case you need, if any of these commands that you've typed in today haven't worked properly, they're down there. So ggplot exercise is here. Here we've got commands for scatter plots. There's types of scatter plots. For bar charts of count data. And then we've got bar charts for mean data. And we've also got how to do a grouped bar chart, again of mean data. And there's also this really nice ggplot cheat sheet. It's just two-sided A4 sheet of paper that's got a lot of the different arguments that are used in the ggplot function. The second exercise is if you want to just try getting your own data into R and start managing the data, or maybe even run analyses, if you're ready to do that, then I'd recommend you get started. If you're not quite ready to do that, or maybe you don't have any data yet, you can try the questions which use a really famous data set. Sorry, famous among our users. It's called the MT-CARS dataset, and we've given you solutions if you need them. So if you scroll down here, we've got this dataset here. It explains what the dataset is, and then we've got some questions that you can tackle. And feel free to copy and paste the code from above when you're answering these and just adapt it. But if you get stuck, or if you want to check if you've done it correctly at the end, then you can do this. But again, there's lots of ways of doing the same thing in R, so if your code isn't exactly the same as this, don't worry. That's it. Good luck using R.